Good day viewers, welcome back to our math class. In today's class, we are introducing you to Fourier Series. This is giving us f of x is equal to a naught over 2 plus the summation as n starts from what? 1 to infinity an cos nx plus the summation as n starts from what? 1 to infinity bn sin nx, where our a naught, an and bn are coefficients of what? They are the coefficients of the Fourier series. Now, what is the value of a naught? What is the value of an? And what is the value of what? Of bn? Our a naught is giving us 1 upon pi, the integral of minus pi to pi, the given function that will be given to find, which is f of x dx. Then our an is equal to 1 upon pi, the integral of minus pi to pi, f of x cos nx dx, and the bn is equal to 1 upon pi, the integral of minus pi to pi, f of x sin nx dx. So this is what? This is the value of the coefficient of what? Of the Fourier series. Now the next thing that you have to learn is that once you are dealing with period 2, if the function that you are given is even, you have to take down these three stuff now. If 1, if the given function is what? Is even, therefore the bn must be equal to what? Is 0. And once your bn is equal to 0, the next thing that you do is what? You calculate for a naught and what? And an. And the Fourier series of the even function now is now giving us a naught over 2 plus the summation of n starting from 1 to infinity an cos n what? X. Because this part of the Fourier series, this part, you see that what? If that function is even, this your bn will be what? Is 0. Once this bn is 0 now, once this our bn is 0, what will happen to this place? Everything will vanish. So you only have this part left. You only have this part left. So this is the part that you use for what? For even function of period 2. Let's continue. 2. If the given function, which is this, is what? Is odd, therefore a naught is equal to what? Is 0, and an will also be equal to what? Is 0. And this now implies that what? That we have to calculate for what? For bn. And once we calculate for bn, our Fourier series will be what? F of x is equal to what? The summation as n starts from 1 to infinity. Bn sin nx. So this is what you are going to have for what? For odd function. Because why we having this value for our what? For our odd function is that this part of the Fourier series, this part of the given Fourier series now, the value of this one is 0. The value of this one is 0. So the entire part of this list turns towards is 0. What do you have left? You really have this guy left. Which is saying that what? This is saying that what? The Fourier series for what? For odd functions. So let's continue now. The last one that we are going to discuss, that which is the third one. If the given function is neither even nor odd, that is, that function is not even and it is not what? Odd function. So therefore, what are you going to calculate for? You are going to calculate, for a naught, an, and bn. Now this is now going to give us the first formula that we have above, which is same thing as what? Which is same thing as this formula. So when you have a function that is not, that function is not even and is not odd, this is the Fourier series that we are going to use. Now let me write it out as what? As our Fourier series. So this implies that the Fourier series is equal to a naught over 2 plus the summation as n starts from 1 to infinity an cos nx plus the summation as n starts from what? 1 to infinity bn sin nx. So we are going to make use of the third one for any function that is neither even nor odd. But if the function is odd, we make use of what? This our second one. And if the function is what? Is even, we are going to make use of what? Which of these one? The first one over here. So in this case, what you have to understand before you make use of your Fourier series is that you have to ascertain and confirm if the function is what? Is even or odd, and if the function is not even and odd. So once you can identify that, you'll be able to solve most of the question on Fourier series for period 2. Kindly subscribe to Rock Math Class for more exciting video. Bye bye.